Alright, it's Mr. P Helps with Calculus. This is Unit 1, Day 6. And in this lesson, we're going to be talking about end behavior. So this is approaching either positive infinity or negative infinity, which basically means the function as you go further to the right, to the left. We're exploring how that behavior changes depending on what type of function that you might have. All right, so this lesson is basically going to take a lot of information about prior knowledge about previous functions that you've learned in the past and be able to describe what the behavior or how the function tends to behave at either end of the function. So for example, if you have a cubic function, then you should know that the graph should look something like this. Now, it might look something different in between, but it doesn't really matter because all we're doing is trying to explore what's happening at either end, these end behavior. What happens in between does not really matter to us. So these numbers obviously would change some things, but this is a positive leading coefficient, which means that we know this function is going to be always increasing, or at least increasing on the ends, I should say. It could have a dip in the middle. But that doesn't really matter because, like I said, we're only exploring end behavior. So the further I look to the left, the further this graph is going down towards negative infinity. Because you remember, we're looking for the limit. We're looking for the height at that point, and it is approaching negative infinity. The further I go to the right, the further this graph goes up towards positive infinity. Same thing goes for when the function, if it's a cubic function, if it has a leading coefficient of a negative number, then we know the graph is always going to be decreasing, with the same caveat that we don't know what's in the middle, I should say. Okay, so further I go to the left, further it goes up, so therefore this is positive infinity. Further I go to the right, the further this graph goes down towards negative infinity. All right, so now let's take a look at some squared functions, or quadratic functions. So if this is positive, you know that it's going to make a parabola shape, which is always going to be going up. So whether this is positive or negative, it does not matter because both sides, both negative and positive, are both going to be going up towards positive infinity. But if you have a negative coefficient, then you know that both sides are going to be going down towards negative infinity, no matter what this is. So this happens to match this side end behavior, but had this said positive infinity, it would have been the exact same answer anyway. Now, we have here, so E. So E represents Euler's number. And Euler's number is roughly, because it's irrational, it goes on forever, it's 2.71. And that, you should know that 2 to the x power, which is the parent function, would look like this, with a horizontal asymptote at 0. Well, Euler's number isn't that much different than 2. It's just going to go up a little bit faster. So it's going to be the exact same kind of curve, or hyperbola. Now, if the further I go to the left for negative infinity, the closer and closer it's going to get to that horizontal asymptote of 0. The further I go to the right, the closer and closer it's going to get up to positive infinity for a height. Now, same thing goes. So if you have that general understanding of what the graph looks like, it happens to look like this, then you know that it's going to be going to the left up towards positive infinity, and to the right it's going to get closer and closer to that horizontal asymptote. Before I go further, I do want to kind of explain how this is used for other functions. Now, sometimes you're going to see functions that are a lot more complex than this, and something that's possible to a really, really big number. Now, if I make x a really, really big number, think of e to the negative x as really 1 over e to the x, because if you have a negative exponent, you can just flip it. So my microphone keeps cutting out, sorry. So if I make it a million, 2.71 to the millionth power is some ridiculously large number that we... So 1 over a really large number that we can't comprehend will obviously be close to 0. 0.000, a billion zeros, and then finally you get a number. That's essentially 0. So yeah, it does make the answer does end up being 0. All right, so now we are going to learn about, so we have polynomials. It's one way to do end behavior, and this ends up being a nice easy trick, is you just look at the coefficient, you look at the degree of the top and bottom. If the degrees on top and bottom, and by degree what I mean by is the largest exponent. So if you have a polynomial on top and bottom, so this has a 2, this has a degree of 2 also. If the degrees are the same, then that's easy because all you have to do is divide the coefficient. So the answer here is 5/3. The degree up here is 3, the degree down here is 3. Doesn't matter if it came first or second, doesn't matter. So we really just have 4 over negative 2, and that's your answer. That's only if the degrees are equal does that work. Now, what if the degree on top is bigger than the degree on bottom? Now, you should have learned back in Algebra 2 that's going to be a slant asymptote. It looks kind of like this graph that you see right here, matter of fact. So you've got this slant asymptote. It's not and a vertical asymptote, a matter of fact, in this case. But the only thing we care about is the slant asymptote. And why is that? Because the slant asymptote is going to tell us whether or not the function's either going up towards positive infinity or down towards negative infinity. Because let's be honest, when the graph looks like this, there is no other option. Either it's not going to go at a horizontal asymptote, it's on a slant, so therefore it can't be a solid number. It's either got to go up or down. That's it. Those are your only two choices. So really the only thing that matters here is whether or not the slant asymptote is going up or down. Now, you could divide the top divided by bottom and figure out what the slant asymptote slope would be. And that is one way of doing it. And you end up getting like negative 1/6, which tells you that the further you go to the right, if it's going down the slant asymptote, obviously the further you go to the right, the further it's going to go towards infinity. And this one happens to be a negative, which is going to do the exact opposite. So that slant asymptote is going to be positive. So the further you go to the right, the further you go to the right, the further it's going to go down towards negative infinity. Now, obviously, if this is a really big number, a negative really big number over a big number is going to equal a negative really big number. It kind of just makes sense if you just think of it in terms of a big number. If you put this big number into here, right, and this is bigger than this, it's obviously going to be a negative big number over a big number is another negative big number. Same thing goes for here. Big number to the third power over big number to the second power. Well, the big number on top is going to be bigger, and it's going to end up being positive. Now, what if the degree is bigger on bottom? And that is actually the easiest case of them all. So here you can clearly see the 3 is bigger than the 2. It's always going to have a horizontal asymptote of 0. So that's a pretty quick and easy thing that you can just memorize. So once again, if it's equal, then you just use the coefficients of the top and bottom. If the top is bigger, then you know it's either positive infinity or negative infinity, and just think about which direction that slant asymptote is going. And then if it's less on bottom, the answer is 0. I'm sorry, if it's less on top, then it's 0. All right, so using that, here are some practice problems. So the limit is this. Keep in mind, this only works if you're trying to find the limit for end behavior. This does not work for anything else. So if this had said 2 right here, don't just assume the answer is 0 for this question, just because this is bigger than this. But since the degree is larger on bottom for this one, obviously it's 0. This one, the degrees are the same, so it's 6 divided by 2 is 3. This one, the top is bigger than the bottom, so obviously it's a slant asymptote. So I could divide top divided by bottom, and I can find that obviously it's got a 1/10 x, which means it's slanting up, which means the right side would be going up, and then the left side would be going down. Since it's asking for right-hand end behavior, the answer would be positive infinity. But well, let's be honest, if the top is bigger degree than the bottom, you know the answer is either positive infinity or negative infinity. You got it down to 50-50 chance, just got to find that slant asymptote. And it's always going to be obviously the opposite. This is a negative, this is a positive. So negative divided by positive is a negative. 10x times 1/10 is just x squared. Yeah, that works. Does it? All right, I had to stop it to check myself. I knew something was up here. Yeah, that doesn't really make sense. This had to be a negative. A negative had to be the opposite. So a negative times a positive is a negative, and we subtract a negative from another negative. We've changed. That's going to wipe each other out. So yeah, this should have been decreasing. So this slant asymptote is going down towards infinity, and therefore the further you go to the right, the further it's going to decrease. So this actually should have been negative infinity. Find the horizontal asymptote of y equals x to the negative first. Well, x to the negative first is the same thing as 1 over x, and this is clearly what 1 over x looks like. Obviously, the degree on the top, you can think of this as x to the 0th over x to the 1st. The top is smaller than the bottom. And what do we do when the top is smaller than the bottom? Well, the answer is always 0. It's got a dotted line. It's got a horizontal asymptote at 0. So quite an easy one there to end on. Thanks again for watching, and I'll see you in the next video.